The Great Wall of China extends over 21,000 kilometers. It traverses diverse terrains, including mountains and deserts. The wall also crosses rivers and other natural obstacles. It was constructed without modern machinery. The Great Wall exemplifies ancient engineering and manpower. Construction began in the 7th century BC as separate defensive walls. These walls were built by various Chinese states for protection. In 221 BC, Emperor Qin Shi Huang unified China. He ordered the walls to be connected and expanded into a larger system. The Great Wall was rebuilt, strengthened, and extended over 2,000 years. Multiple dynasties contributed to the wall's construction and evolution. The most famous sections were built during the Ming Dynasty. Ming Dynasty construction occurred between the 14th and 17th centuries. Desert regions utilized locally sourced materials for construction. Compacted sand is a primary building material due to its abundance. Gravel is also used, providing structural support and stability. Reeds are incorporated for insulation and binding elements. These materials are suited for the arid desert environment. Mountainous regions often utilize locally sourced materials for construction. Cut stone and granite blocks were common choices due to their abundance. These materials offered durability, crucial in rugged terrains. Granite's strength provided stability for structures built on uneven ground. In flatter regions, rammed earth and bricks were commonly used building materials. Rammed earth provided a solid, dense foundation for structures. Bricks offered uniformity in construction and enhanced weather resistance. These materials were well suited to the plains environment and resource availability. Rammed earth construction involves compacting soil layers between frames. Workers use heavy tools to pound each layer tightly. This process is repeated to build up the wall structure. The result is extremely hard, dense, and durable walls. Brick production saw a dramatic increase during the Ming Dynasty in China. The bricks produced were significantly stronger than previous versions. Bricks were also more uniform in size and shape, improving construction. The new bricks exhibited enhanced resistance to various weather conditions. Some mortar mixes incorporated sticky rice with lime. Sticky rice enhanced mortar's binding properties. This rice-lime mix improved the mortar's durability. The enhanced mortar ensured structural integrity of walls. The Great Wall's construction spanned centuries. Millions of workers contributed to its building. Soldiers were a significant part of the labor force. Farmers were also conscripted for wall construction. Prisoners and forced laborers were used in construction. The Qin dynasty conscripted vast numbers of workers for large-scale construction projects. Hundreds of thousands were dispatched to remote areas to build the Great Wall. These workers faced extremely harsh environmental and working conditions. The labor was physically demanding and often dangerous. Many workers suffered greatly due to the severe conditions during the Qin dynasty. Desert construction sites present harsh working conditions. Extreme heat is a primary hazard for desert workers. High temperatures lead to rapid dehydration. Dehydration causes exhaustion, reducing work capacity. Worker effectiveness is significantly impacted by these factors. Mountain workers faced extremely cold winter conditions. Freezing temperatures led to a high risk of hypothermia. Slippery conditions increased the chance of accidents. The combination of cold and ice created hazardous work. These conditions severely impacted worker safety and health. Limited food supplies posed a significant logistical challenge. Dangerous terrain complicated food distribution efforts. Harsh working conditions were exacerbated by food scarcity. Malnutrition became a common issue due to inadequate food intake. Decreased productivity resulted from the combined effects of these challenges. Historians suggest high worker mortality during construction projects. Thousands may have died due to accidents on site. Disease outbreaks also contributed to worker deaths. Harsh working conditions further increased mortality. These factors combined led to a significant loss of life. The exact number of deaths remains a topic of historical debate. Manual labor was essential for material transportation. Workers carried materials by hand. Shoulder poles aided in carrying heavy loads. This highlights the reliance on physical strength. Animal carts enhanced material transport efficiency. They offered a better alternative to manual carrying. Carts were especially useful for long distances. This improved logistics and productivity. In winter, transporting materials presented unique challenges due to friction. An innovative method involved transporting stones over ice. The ice surface significantly reduced the frictional resistance. This approach streamlined the movement of heavy materials. It showcases a creative solution to logistical problems in winter conditions. Ramps were essential construction aids for ascending steep slopes. They facilitated the movement of materials uphill. Ramps were built using earth and timber. This enabled workers to transport heavy loads more efficiently. The ramps reduced the effort required for material transport. Human chains involve workers forming a line to pass materials. This method aids in transporting items where direct access is limited. It's a collaborative approach to logistical challenges. Workers pass materials hand to hand, improving efficiency. Human chains are useful in construction and disaster relief. This method highlights teamwork and coordinated effort. Watchtowers were strategically positioned along walls. They were typically spaced a few hundred meters apart. Watchtowers served as elevated observation points. Their primary function was to monitor enemy movements. Signal towers facilitated long-distance communication using smoke signals. These towers were strategically positioned for maximum visibility. Smoke signals enabled rapid dissemination of information across vast areas. This quick communication was crucial for responding to potential threats. Signal towers played a vital role in early warning systems and defense strategies. The wall was a component of an advanced military communication system. It facilitated rapid dissemination of critical information across the network. The system enabled quick coordination of defense strategies. This ensured a unified and responsive defense posture. Real-time updates allowed for adaptive strategic adjustments. The wall was integral to maintaining a strong defensive network. Drainage systems are engineered to protect structures from water damage. They ensure the long-term structural integrity of walls and foundations. These systems are crucial in mitigating the effects of soil erosion. Effective drainage prevents water accumulation around structures. This reduces hydrostatic pressure and potential foundation cracks. Preservation efforts are ongoing at this UNESCO World Heritage Site. These efforts aim to protect the site's historical integrity. A key challenge is balancing tourism with preservation. Tourism can generate revenue for site maintenance. However, excessive tourism can damage the site.